Hello everyone. So today I'm going to take a lecture on Introduction to Soft Computing. Well, before starting with the introduction to soft computing and elaborating on what is soft computing, I would like to tell you some background regarding this soft computing. That is certain terminologies we are going to use. That is, first is machine intelligence. Basically, what is machine intelligence? We know that there are two terms, machine and intelligence. So machine is any tool that is being programmed or that is being operated with the help of a human being and is used for performing a specific task. And intelligence is related to human brain. That is, it has certain characteristics and abilities to learn, to problem solve, to decide for decision making, and so many more things. So basically, machine intelligence, if I define machine intelligence, it is a machine which is being programmed with certain aspects of human intelligence, including learning, problem solving, and prioritization. With these abilities, a machine can tackle a complex set of problems. So this machine, which has certain amount of intelligence, can help us in solving certain problems. Now, basically, in machine intelligence, we use two types of computation for solving the problems. The first one is called as the hard computing, and the second one is called as the soft computing. Before understanding soft computing, why we need soft computing, we are going to discuss hard computing. So what is hard computing? Hard computing is nothing new. It's the old conventional technique we are using since long. Well, in computer programming, whenever we design an algorithm, our action is based on certain logic. I'll say it is based on certain logic. That is, if answer is yes, then we have to perform a set of specific tasks. And if the answer is no, then we are going to perform a next step of task. In all these situations, we are going to get a definite answer, that is a correct answer, right? There are not other possible answers which are in this. Now, let's take an example. When we define in computer programming, let's take an example. The example is very basic one. That is, we are going to define the result of a student, whether the student is pass or fail, depending on the logic, that is, whether a student attains 40% marks or greater, then the student is pass. And if the student is attaining less than 40% marks, then the result of the student is fail. So I'm going to give a input. That input will be very specific. Let's say 44. Then the answer is yes. That is, the condition is being satisfied with the condition, that is, the student is attaining more than 40% marks. So because 44 is greater than 40. So the answer is, that is, the student is pass. Else, if the input is 24, then the condition says that it is having less than 40% marks. Hence, the student is failing in the exam. So I get a specific answer with the specific exact input. So this particular type of computation is called as hard computing, which is used in conventional techniques and is being used today also. Well, there are certain main specific characteristics of computing, hard computing. That is, it uses or follows a mathematical model. It always requires exact input data that should be precise. It generates a precise output that gives you or make a crisp system. Now, what is this crisp terminology? This crisp means, that is, I'm getting an exact output, that is clear output. Crisp means clear. So when I say in binary is crisp. That means either 0 or 1. So this is what crisp is. Now, there are certain examples I have taken through conventional algorithms and through computing, hard computing. Those are merge sort, quick sort, binary search. greedy algorithm, dynamic programming, all these we have studied, and these are coming under the category of hard computing. Why hard computing? Because it has a specific input. It gives certain output that is clear and specific and exact. So now, what is the drawback of this hard computing? The drawback of hard computing is these algorithms or computation fails whenever we do not have exact input. That means it fails when the input is not exact, which make it inefficient to solve real world problems, because in real life problems we do not have every time exact input. At times the input is not clear, at times the input is not certain. So in this particular scenario, the hard computation technique will take longer time and will have large computation time, and if at all it gives result, it is going to give an inefficient or non-optimal result or solution. Example, prediction of weather. Whenever we are going to predict the weather, that is whether the tomorrow it is going to rain or not, then I do not have any exact input for this. I have certain statistics I need to analyze. So in this particular scenario, for prediction of weather, the hard computing will not give me an optimal solution. For that particular purpose, here comes the solution. That is, the solution is soft computing. So that means the role of soft computing is coming under the category, under the scenario, whenever we do not have exact or precise input or parameters. How do you compute the result for these particular scenarios? The answer is soft computing. So I hope now this is clear why we are using soft computing, why we need to switch on to soft computing for an advanced technology. Now, basically, let's understand deeply what is soft computing. Taking up the complete definition of soft computing, let's see the definition. Soft computing is a collection of methodologies that aim to exploit the tolerance for imprecision and uncertainty to achieve tractability, robustness, and optimal low-cost solution. It is also called as an emerging approach to computing, which parallel the remarkable ability of the human mind to reason and learn in an environment of uncertainty and imprecision. So now, the drawback or the problem we were facing in hard computing was that it does not tolerate the imprecision and uncertainty. That means we need to have a precise input, exact input, certain. The conditions should be certain. But here, soft computing is going to work on the principle of exploiting the tolerance for imprecision and uncertainty, and is going to give you a optimal low-cost solution. So let's see what are the goals of soft computing. Its basic aim is to mimic human intelligence. Obviously, whenever the real life situation comes, human intelligence is needed and the machines fail. That is, the basic computer programming and hard computing fails. That is why we are working on human intelligence mimicking through soft computing. Now, second goal is to compute solutions for the problems which does not have an exact solution. We have already talked about this. That is, we use soft computing whenever we do not have any exact solution for the problem. To provide solutions to real world problems which are not modeled or too difficult to model mathematically. If we are going to follow a mathematical approach, a simple mathematical or statistical approach, that comes under the category of hard computing, where we have a definite or a precise exact input and the output is not exact. Now, this is the basic principle of soft computing, with the help of which it is working to the mimicking of human intelligence. That is, to exploit the tolerance for imprecision, that is not precise, uncertainty, not clear, partial truth, that means there is certain value which is between true and false. that is partly true or partly false, neither true nor false, and approximation, that is not clear and not exact. Now, we can see certain examples, or I would say that these are the applications, few applications where soft computing is being used. Obviously, soft computing is being used in complex real-world problems. So it forms the solution for predictions of stock market and business, weather prediction, computer-aided diagnosis, that means it gives you a specific and clear diagnosis of many diseases. Handwriting recognition in fraud detection, that means if someone is trying to, use someone's handwriting and try to mimic it, it will give you a clear understanding and it will recognize the handwriting. Image retrieval, etc., etc. These are also used in few games, maximum games, where you can see that chess, let's say chess example, where there are only two players and one is computer itself and the other one is maybe you. So there the computer is always trying to learn from its own. That means the computer is trying to develop or make better rules for playing the game in a better way and learning from its own mistakes. Now, what is the basic difference between hard computing and soft computing? This is just a, the conclusion, or I would say the overall slide which is coming under the category, that is soft computing have imprecision. It works on the principle of imprecision, uncertainty, and partial truth, while hard computing works in precise and accurate principle. Now, it follows fuzzy and probabilistic reasoning, while hard computing works on crisp or binary. I already told you crisp is, either true or false, very clear answer, and in binary form it's 0 or 1. While when I say fuzzy and probabilistic, we are going to work on probability. Let's say if I am going to ask whether it is going to rain tomorrow or not, so it is not clear. The answer will be, the input is not clear. Maybe today it's sunny and tomorrow again it's going to rain, maybe or may not be. So we need to do probability analysis, reasoning, and so many more things to work on this approach and get the result. Now, next difference of soft computing and hard computing is soft computing follows heuristic approach, while hard computing follows a sequence of specific tasks. That means in hard computing, we have a specific algorithm that is sequential. That means it cannot work on parallel. While in soft computing, it can work on parallel and it has heuristic approach. It is not sequential always. Next difference we can understand is soft computing easily operate on ambiguous and noisy data. That means every time it does not need the exact or clear input. While in hard computing, it always needs a exact input data. As we know that we are working for soft computing, it comes only when the data is ambiguous and noisy. It is helpful in that condition. Next, the basic model or this soft computing is based on human brain. That is, I already told you, it is related to mimicking of human intelligence. So that is why it is based on the model of human brain. While in hard computing, it is based on mathematical models. Next, the output. The output of soft computing is approximate, it's not clear, while the hard computing output is always exact. And the last thing is that we all must have understood till now, that is, soft computing is used to solve real life problems. Rather, the hard computing is used to solve mathematical problems which may be complex. So one more thing, that is soft computing is used or has a tendency of stochastic learning, and while the hard computing has deterministic. The stochastic means, that means it learns on its own. That means if I have designed an algorithm and by the time it works and works again and again, it will learn and get better on its own, right? So this is called learning by itself, and this is how it is mimicking the human intelligence. As we learn through the examples and experiences, the algorithm is also going to learn through its experiences, through its mistakes. While hard computing is deterministic, that is, it works on exact problem and exact solution, and we already know that this is the algorithm and it will not make itself better through the time. So this is all for today's lecture: hard computing, soft computing, and difference between both of them. Thank you.